All right, so as we're trying to prove the cofunction identity, we're going to use the difference formula. Now it's just a matter of plugging things in, okay? The u in this case is going to be our pi over 2, and the v for our formula is just the x. So we're going to plug those into our formula. So we have the cosine of pi over 2, okay, times the cosine of x plus the sine of pi over 2 times the sine of x. Okay, so there's our formula that we're using. We've plugged everything in. Okay. Now we have some values that we should be able to simply plug in. What is the cosine of pi over 2? It's 0, okay? So now we have 0 times the cosine of x plus, what's the sine of pi over 2?
1.
1. So we have 1 times the sine of x, and that's obviously 0 plus sine, which is sine, okay? So there we have a simple proof of our cofunction identity. Okay? We could do this with our other trig functions. For example, tangent of pi over 2 minus x would equal cotangent of x, all right? Our other cofunction identities. We could even work out the secant and cosecant one. We'd have to get a little creative because we don't have a secant formula, but we could work out something else using the cosine. Okay, so I do want to look at two other examples here. Here we have the cosine of theta minus 3 pi over 2. Okay, now as we look at cosine of theta minus 3 pi over 2, notice it says here we're deriving reduction formulas. These are formulas that you could use, say, if you were using a particular process that called on you to measure an angle, but then do something to that angle, and you were going to be doing this a number of times. It would be helpful to be able to just write that as one more simplified expression, so you're not having to do the process over and over and over again. Okay? We could see if this comes out to anything simpler than having to actually subtract the 3 pi over 2 every time we're doing it. Okay? So again, we're going to use the same formula that we had before here for part A. Okay, we have the cosine of u times cosine of v. So it's cosine of theta, and I'm just going to use x for simplicity, times the cosine of 3 pi over 2. And then, what's it going to be, plus or minus? Plus the sine of theta, or x, times the sine of 3 pi over 2. Okay? Okay? So now we're going to go from here and we're going to actually plug in values that we know. All right? So we have the cosine of x times, what's the cosine of 3 pi over 2?
0.
It's 0, okay? Cosine is the x-coordinate, right? So it's 0. And then we have plus sine of x times, good, sine of 3 pi over 2 is a negative 1. So you can see here we get 0 plus a negative 1 sine. So that's a negative sine x. Okay? So, rather than doing theta minus 3 pi over 2 every time, we can just do a negative sine of theta. Okay? And it simplifies whatever process we're using there. Now, switch this over, pull this over here. Okay. Now let's try tangent. We haven't actually done any ones using the tangent formula yet, but let's try this one here, okay? So, first of all, what's our formula for the tangent?
Tangent u plus tangent v over 1 minus tangent v times tangent v.
Okay, you have the sum of the tangents over 1 minus the product of the tangents when we're doing the tangent of a sum. So it's tangent, I'll call it x again, tangent x plus tangent of 3 pi, and that whole thing is over 1 minus tangent x times tangent of 3 pi. Okay? Now, question, what is the tangent of 3 pi? Alexi?
The tangent of just pi.
That's right. Coterminal angles have the same trig function. So what's now the tangent of just pi?
0.
0. Yes. Sine of pi is 0. Cosine's -1. 0 over -1 is 0. So look at what we've got. We've got the tangent of x plus 0 over 1 minus tan x times 0, right? So that's just going to be 1, right? So look at what we've got. We have tangent of x over 1, which is just tangent of x, of course. Okay? So we actually find out here in this case, we don't even have to add the 3 pi to both sides, or to the angle every time. We can just use tangent of x, and we'll get the same thing. If you think about your unit circle, that makes sense, you know, because tangent is positive in the first and third quadrant. Those are pi apart, okay? And it's negative in the second and fourth quadrant. Since those are kind of catty-corner to each other, those are pi apart. All right, so if you needed the tangent of, if you had an angle of, say, pi over 4, if you're adding 3 pi, you're going around a full circle and then another pi, that's going to put you in the third quadrant. It's going to be the same thing because the reference angle is the same as well and the sine is the same. All right? So this one makes sense logically, but we just proved it as well. Okay? Make sense? All right? Just a couple examples, but there's a lot of different things that you can do with these. Now, I'm going to give you some of these to try. Here's one harmonic motion problem you can try. Here are a couple others. You're trying to find the solution to the equation. Okay? Don't use your calculators and just plug stuff in. All right? Use your unit circle. Use your formulas. Okay? Here you're verifying a couple of trig identities. This first section, though, I want you to make sure you pay attention to this. And also, remember the ranges. Okay? The range of the inverse sine was what? What's the range of our inverse sine? Remember, we had to limit the domain. Yeah, there we go. We had to limit the domain of the original function, sine, so we had an inverse function. So it's negative pi over 2, 2 pi over 2. Okay? Does this ring a bell? You remember this? Okay. How about inverse cosine? What was this one? No? This is the different one. What? We could have done pi to 2 pi, but there was the one we normally do is 0 to pi. 0 to pi. Okay? pi to 2 pi would have worked, but no one uses it. But and that's what your calculator will give you too. Remember, if you do inverse cosine, you're always going to get an answer from your calculator that's between 0 and pi. If you do inverse sine, you're always going to get an answer from your calculator that's between negative pi over 2 and pi over 2. How about tangent? What?
Negative pi over 2 to pi over 2.
That's right. It's negative pi over 2 to pi over 2. Okay? So keep those in mind as you substitute in. What I would do with these, first of all, figure out what these equal. Okay? What is the inverse sine of negative 1? Okay? Within this range. And then you're able to plug those in. Okay? So I'm going to give you the remainder of the time here to practice. Okay? You can work with somebody. You can skip around to different sections. That's fine. I'm going to put this up online so you can bring up the PDF in just a minute. But you do need to work on this. All right? So let's get going.